Okay, I'd like to help you guys with some of the word problems on section 4.8. There are really three basic word problems, but here's the thing. On all of these, what the goal is to write an x squared term, is to get an equation either in the second or the third, and then be able to factor this. So what you're trying to do in writing your variables is trying to get a squared term or an equation in the second or third degree so that you can then do the factoring that we've been doing. So the first one I have is number 9. Now if you read through number 9, and again I'm on page, for you guys, I'm on pages 200 and 201 so that you can follow along. So this is number 9, and number 9 talks about a ladder leaning against a building. So this is the ladder here, and the ladder is 15 feet tall, and it says it leans up against a building, and it's a certain amount higher here than it is from the base. So here's our geometric figure here, and it says that the height here where the ladder rests is 3 feet more than at the bottom here. So this is x plus 3. Now especially you guys from last year, you should quickly recognize that is 90 degrees, which makes this so that we can write a squared, if you will, that squared plus that squared is equal to that squared, which is Pythagorean theorem. So I'm not going to do all of this for you, but that means that we can take x squared plus x plus 3 squared, set that equal to 15 squared. And again, I've got these written out for you. This is 225 is equal to x squared plus 6x plus 9. Okay? Now, I'll tell you that I'll skip down here, and this is an interesting thing here. You should get to the point where you have 0 is equal to x squared plus 3x minus 108. Now, that needs to be factored. So you have x and x. Now, the easy way to do this, of course, is if you come over here, is that this 108 factors to 2 times 27, but that's not going to add up to 3, no way. So that is equal to 4 times, excuse me, this is 2 times 54, sorry. So this is 4 times 27, that still doesn't work. So this becomes 12 times 9. Okay? So let's do another one, and again, this was number 9, sorry, that's number 9. Let's do another variation for you on this. Let's do one of the rectangles. So I have for you number 14. Let's go through this one quickly. So 14, we have a rectangle, and it says, look, in the basic rectangle, the width is x, and the length is twice the amount of the width. Now it says, look, let's expand both of these so that the width, excuse me, the length is 4 more length, and the width is 3 less, is equal to the width. Now again, how can you use these two expressions here to write a polynomial? Well, we know that the area is equal to 116 square centimeters. Okay? So 116 square centimeters is equal to length times the width. Okay? And I'll let you solve from there. Alright? And the third one, which is really a little bit harder. The third one talks about velocities. And I'm going to talk about number 19 so you can follow along. But the book gives you a piece of information in a formula. It says that, look, the height of a projectile is equal to its velocity times the time And in this case, in metric, it's minus 4.9 t squared, where this is t. Okay, so this is standard. So look, the rocket goes up, it runs out of fuel, it goes up a ways more, and then it comes back down. So that's kind of what we're doing. The hard part about this is that we have to think about height in the round trip. When it's back down here is 0. But it does a round trip here. So V is equal to, in this problem, 245 meters per second. And H, because it ends up back where it started, is 0. So we need to plug in here. Time is what we're trying to find here. So we can say that 0 is equal to 245 times t minus 4.9 t squared, which is equal to 245 t minus 4.9 t squared. And again, this is 0, which is nice. That's what we've been doing all along. Factor out conveniently 4.9 t. And we're left with 50 minus t, all equal to 0. And again, from here, I'd ask you to grind out the information for t and then solve for the other factors, how high, etc., that this has gone, and do the other parameters. That gives you 3 good sample problems for section 4.8.